Today we'll cover something more visual and perhaps exciting called the image processing library, OpenCV. Yes, it is a new library. OpenCV is widely used in industry and you can build complex tools out of it, but at the same time it's quite easy to get into, so please don't worry about the difficulty. Here's an outline of what we're going to do today. Pause the video and familiarize yourself with the big words like OpenCV, pixels, and RGB. Also make sure that you do not watch this video before learning NumPy. There's a previous video tutorial about Python library NumPy, so please watch it before you proceed any further. First, what is image processing? How does the library OpenCV allow that? Image processing is a computing method to perform some operations on an image in order to get an enhanced image or to extract some useful information. So broadly defined, any change made to an image is considered image processing. It can be applied anywhere: face unlocking, self-driving cars, MRI, video analysis, and Photoshop, etc. OpenCV is a leading library in image processing. In the word OpenCV, open means open source, and CV stands for computer vision. OpenCV is accessible through both Python and C. What do you think this means? You can write OpenCV in the Arduino kernel, which uses a C language. But in this tutorial, we'll only focus on its Python version. OpenCV contains all fundamental image processing functions: drawing, editing, edge detection, object detection, etc. And the most important part, it treats images like NumPy arrays. We'll see how it does that. The installation process can be either complex or easy depending on your situation. First, open the terminal, which is called command line prompt or CMD in Windows, and type pip install OpenCV Python. If you don't see any error, you can proceed, but there are many reasons why this might not work because OpenCV requires a very specific version requirement or dependencies to be installed. And the most frequent reason is your Python or NumPy version is too new or they have some inconsistent versions. For developers, it is always the best practice to download slightly older or stable files. Send me an email if you still face errors, and in the Google Colab environment that I used last time, OpenCV is pre-installed, so try using Google Colab if it doesn't matter whether you code locally or virtually. So why are images arrays? When the computer retrieves an image, and here I'm saying colored image, it first breaks down the image into three channels: red, green, blue, also known as RGB. These three colors comprise white light, by the way. Each channel, red, green, blue, is then converted into a 2D array. Since there are three channels, we can consider this all together as a 3D array with a depth of 3 because there are, three channels. And each cell of the array corresponds to a pixel. For example, when you see that resolution of your laptop is like 1920 times 1080 pixels squared, this basically means that when the display is broken down into three channels, it can be interpreted as 1920 times 1080 times 3 pixels cubed. So a value in the cell represents intensity or brightness. The highest intensity is 255 and the lowest intensity is 0. And when OpenCV reads an image file, it converts the image into a 3D array where each value can range from 0 to 255. And here's a picture that might help you recall what the arrays were. Next, we'll learn how OpenCV can handle these functionalities. In the Python script, import OpenCV by stating import cv2, just like you import other Python libraries. If you see any error, that means OpenCV was not installed properly. To use the functionality of OpenCV, always call cv2.functionName. To read an image by reading, I mean converting an image file to a NumPy array, remember the function of cv2.imread. And to read an image as a 2D grayscale or black and white as a monocolor, state cv2.imread path to image 0. Notice the second parameter passed into function is 0. The second parameter of imread is called flag, which means how you want the computer to interpret the image. And the default value of this flag is always BGR. So when you don't state any flag, the first channel is going to be blue, second green, and third red. Lastly, to display the image, state cv2.imshow image, where the image argument is an array. Be careful when you use cv2.imshow in Colab because it'll throw an error. Colab doesn't support cv2.imshow. I'll show you how to handle that in the Colab environment in a Finally, the coding part. Build your own class structure with OpenCV functionalities. We'll learn how to do the following with OpenCV. First, transformation, including resize, rotate, crop, arithmetic, splitting, and merging, and color spaces. And second, drawing, including how to draw lines, rectangles, and circles. Then we'll design a class structure while learning new code. You should always remember what class and object are in Python. The reason why I suggest you to do so is designing a class involves an accurate understanding of the code you're writing, because you have to plan out the code according to your knowledge, not just hoping that your code will work if you make some edits. And I'll provide an example class structure for retrieving images to a specific size, and try designing classes or methods with other functionalities that we learned today, such as a class that draws a shape on the image, or a class that can easily transform. Welcome back. You can use whatever text editors that are available to you, but I'll use Colab Notebook because it presents the results of my code much better. To access the image file I'm using, read the description below and download the JPG file. In the Colab environment, you'll have to drag the image into the Files tab to ensure that you can access it anytime. Okay, let's begin. And only if you're using Colab, state this line too. If you're using Colab, know that you'll have to type cv2 underbar imshow, not cv2.imshow. This only applies to the imshow function, so if you want to use other functionalities, call it normally like cv2.functionName. So now let's read and show the image. And then here we'll put the address. For the address, you can put whatever directory that actually points to the location of your image file. And as you can see, the console below, it displays the image with the original size, which seems a little bit too big, right? Let's try decreasing the size. To decrease the size, we simply call the resize function. cv2 imshow image. That's simple, right? Remember, we're visualizing arrays, not the image itself. Since values are indexed from the top left corner in regular 2D arrays, the origin of this display is at the top left. Now let's try rotating the image. M90, CV2, rotate, image, CV2, rotate 90 clockwise. CV2, imshow, image M90, image P90, CV2, rotate, image CV2, rotate 90 counterclockwise. CV2, imshow, image P90. And lastly, image 180, CV2, rotate, image CV2, rotate 180, CV2, imshow, image 80. It works. Next is cropping. You can use index slicing for this rather than to use a function. In OpenCV, seeing is not believing. Even though you think about a cropped image, how a computer interprets it is a table of numbers. We'll tackle this problem by specifying the ranges of x and y and slicing the array. So min x 64, max x 256, min y 128, max y 256. And cropped image slice minimum y, maximum y, minimum x, maximum x. CV2 imshow cropped. The next task is arithmetic operations. Remember, images are arrays. You can change the intensity of the image by doing the same arithmetic operation on every single value in the array. Does this require a for loop? The answer is no, because as we discussed earlier, NumPy vectorizes operations. So image v1 image times 2, cv2 imshow image v1, and image v1 image subtracted by 100, cv2, actually let's say v2, cv2 imshow image v2. Now we'll learn how to modify color spaces. The function we need is cv2 convert color, the first parameter being an image array and the second parameter being flag. Flag is how we want OpenCV to interpret the image. Do we want it to take our image as grayscale rather than the BGR? Huge saturation value, so HSV rather than RGB? Let's try converting to grayscale first. So image gray CV2 convert color image CV2 color BGR to gray CV2 imshow image gray, and also to HSV hue saturation value image HSV CV2 convert color image CV2 color BGR to HSV CV2 imshow image HSV. Finally, let's do some drawing. To draw a red line, canvas 1 numpy zeros 256 256 3, and we're gonna type the RGB color code of red, which is 0 0 256, and CV2 line specify the canvas and the starting point 64 64 and the ending point 192 192 and the color. And lastly, CV2 imshow canvas 1. Alright, and let's draw a blue rectangle. So specify the color, blue 256 0 0, and thickness being 2. CV2 rectangle canvas 1 64 64, and then the ending point 192 192, blue, thickness CV2 imshow canvas 1, and white circle. Let's make a new canvas, numpy zeros 256 256 3, white 256 256 256, CV2 circle, and then the new canvas we made, canvas 2, and the center 128 128, and the radius 64, white, CV2 imshow canvas 2. Alright, now a class design time. Again, creating a class structure out of what you learned helps you understand the materials better. Design a class that other people can use without some extensive knowledge of OpenCV. I'll give you a baseline you can start with. So class image retriever, import numpy as numpy, import cv2 from Google Colab patches, import cv2 imshow, and let's define the constructor. Def init self path none, size none, self path self size self image numpy not a number, and def some method def get item self if self path is not none, image cv2 read self path. If self size is not none, image cv2 resize image self size, return image. And otherwise, if self size is not none, image numpy zeros self size and return image. Otherwise, raise exception. Sorry, no argument received. So this class basically retrieves an image to a specific size. Let's test it out. Retriever, image retriever, content moon JPG to a size of 256, 256. And image retriever get item cv2 imshow image. Yeah, this part should be equals. Okay, looks like it works. Now you can try designing a class with other functionalities on the class I gave you as a baseline file, retriever. Thank you for listening. If you have any questions, please let me know at channylee77@gmail.com.